Hello, everyone, and welcome to Proof and Paradox. Now, this is a class that I'm when I took as an undergrad, something similar to this. This is an intro to proofs class, and it was a very formative course for me, and made me really want to be a math major, made me want to study math for the rest of my life. And I know in calculus we learned a little bit about proofs. We did some proofs, and this is really getting down into what is a proof, and also like building your own skills so that you can prove theorems too. And maybe one day you'll prove an original theorem. So let's get into it. I'm gonna just share the screen and we'll look at the syllabus together. Okay, I put my glasses back on. So this course is Proof and Paradox in Math 3530, Mondays and Thursdays, 11:05 a.m. to 12:30 p.m. Okay, so it's a intermediate class seminar, fall, 5 credits. Excuse me. One of the I'm gonna read this. One of the remarkable ironies of modern mathematics is that the success of its methodology has exposed its own limitations. In particular, the advances in mathematical foundations and logic of the early 20th century precipitated Kurt Gödel's incompleteness theorems, which established that for any effective axiomatic system of mathematics, there are mathematical truths that mathematics cannot prove. Gödel's proof is remarkable for both its philosophical implications and its very ingenuity. To prepare a study of the proof, the seminar will review basic logic, set theory, elementary number theory, and the standard techniques of mathematical proof. Having completed a close reading of Gödel's proof, we will then explore the relations between proof and understanding in a more recent mathematical practice. Students will have an opportunity to strengthen their mathematical reading and writing abilities while engaging contemporary mathematical issues concerning the progress of the discipline, the role of computers in proof, best practices in mathematical exposition. This seminar is recommended not only for the mathematically inclined, but also for students interested in computer science, law, or philosophy. Okay, so my specific area is set theory and logic, and yeah, so the word paradox itself is almost a little controversial because there are things in mathematics, like mathematics can't prove its own consistency. There are statements that are true in mathematics that we can't prove. So that sometimes that feels like a paradox, or something simpler than that. That you can have like this. The cardinality of the even numbers is the same as the cardinality of all the natural numbers. Things like this, when you get to infinity, that seem paradoxical. And so maybe we would also discuss, is something a true paradox, or is it just sort of strange? And we're talking about the nature of mathematics, and I think it's very beautiful that I mean, a lot of people that don't have a lot of experience with math might think that mathematics is sort of this very black and white, dry subject, but actually it's extremely philosophical, interesting, mind-blowing. Okay, and so that's what we're going to get into. And the books we have are these very beautiful books that I hope that you get. You need to get them. Proof in the Art of Mathematics, and then there's Proof in the Art of Mathematics, Examples and Extensions. And this happens to be by my advisor, my PhD advisor, or former PhD advisor, Joel David Hankins. And it's very visual. He's sort of artistic, and I think that y'all are going to really enjoy it. And I will give you reading assignments from that book. Okay, and we'll also look at Gödel's original proof. Okay, Kurt Gödel, it's just an amazing person. Okay, so the prerequisites. I think if you've taken Calc up to Calc 2, then you should be okay with this. I think you can take this concurrently with the multivariable math class. Then we're meeting on Mondays and Thursdays again, and also seminars bi-weekly. You meet with me individually. Okay. Yeah, you can always use. I just use the computer for any kind of software. Okay. Attendance. Okay, I'm gonna say this again. Probably get tired of it, but attendance is so important. And if you miss a class, you miss so much information. And if you ask me what did I miss, it's going to take me an hour and a half to explain to you what you missed, because I put a lot of time into preparing the class, and I know and we do a lot of things in class. So anyway, attendance is so important. And in fact, if you didn't do as well as you wanted on your math test, but you attended all the time, that shows me a lot that you want to try. So it can even boost your grade. Okay. Can also hurt your grade if you do perfectly on all the exams, but you don't come to class. I know I had the temptation when I was an undergrad too, but it didn't help me out at all. So please come to class. And you know, when you come to class, it's hopefully it's fun. We do a lot of in-class problems. Um, so it's really sort of almost like a flipped classroom in that sense because you're doing. I mean, there's tons of material that I have to show you, but it's also important to have some time in class to do a bit of exercises. But there will be homework outside of class also. As far as conferences go, also please just attend the conference. Even if you know worst case I didn't get what I thought I was going to get done, just come to the conference because it just makes everything so much easier. And plus, I make announcements in class, and then people miss things. It's just so much better to come to class. Okay, I'm gonna harp on that. Okay, because I really believe that. All right, in class problems. Yeah. Okay, my cats are getting into it right now. So as far as conference work goes, I just it's really open ended, but I sort of have two preferences or two types of conferences that students usually do for me. And so, for example, I'm just going to use it through example. One student in Calc 2 made an app, like a very nicely designed app that was called Series Calculator, and it calculated whether or not a series would converge using his own idea of how to calculate that, and he approximated. Okay, so that was very cool and very related to what we were learning in class. And then another student did, just an example, I have had a lot of great conferences, did something about American music and how American genres and artists are all connected and how they influence each other, and also about like the mathematics of the music itself, like chord progressions. And so that was extremely interesting. It had a little bit of math in it, but it was something that they were very passionate about and interested in and knew a lot about. So I feel like either do something that I know a lot about, like do something in math or something in set theory that I know a lot about and I can help you, or do something that you are very passionate about that you know about a lot about, and then I can learn also. But it has to have some kind of mathematical content. So yeah, so don't pick. I have had maybe don't pick something that neither of us know anything about. It's best if you pick something that like that I'm interested in. I mean, that's just the way it goes. I remember with my teacher, like my if I pick something that he was interested in or knew a lot about, it just makes the project go better because then he knows something about it. So same thing. If you pick something that I'm interested in, and if we're both interested in it, great. Okay, but it's pretty open ended. We'll talk about it. Okay, additional help. There's great tutor here. So please go see the tutor. Self evaluations are also expected at the end, so you'll keep track of your own attendance and things like that. And so other than that, let's see, academic integrity. You can read all of that. Okay, that's all I was gonna say. I hope you're having a great summer, and I hope you're excited for this class because I'm sure excited to get into it. And hopefully by the end we'll have some kind of understanding of what is mathematics itself. And also, I really hope that you're going to start gaining your proofwriting skills and you'll be able to write your own proofs, so that one day you go out there and prove something new. Okay. Well, I look forward to seeing you guys, and I'll talk to you later.